Hi, it's Troy here. So it's finally time to get rid of the hand-wired boards on my HPC 56 6502 homebrew computer and replace them with custom PCBs, thanks to PCBWay. So let's get into it. I'd like to start out by thanking this video sponsor PCBWay, who provided the PCBs. So more on PCBWay later in the video, and there will be more videos to come covering the various custom cards that PCBWay have provided for this project. So this is the schematic I've come up with. Basically it's just the 65C02 CPU, the 65C22 VIA, which I'm using for SPI, and the glue logic, which I'm just implementing with two PLD or GALs. So there's one for I/O, which will interpret 7F 00 to 7F FF as I/O and the rest as memory requests. It will also enable the VIA and the interrupt controller on their addresses. The other GAL is the IOQ controller. It's not so much a controller, but it enables me to have multiple IOQ signals and to query which one is the one currently active. And it also has an onboard clock. So we'll go to the PCB. For the most part on this one I've just used auto routing. It's got 4 layers. If we go to visual, so I have a ground layer which only has ground on it, no traces. VCC layer which does have some traces, but for the most part I've kept them on the top and bottom layer. And so I'll just view this in 3D. And so that's it, and I think I'll order it in black. That should look pretty cool. So for having these PCBs manufactured, PCBWay have been generous enough to provide these for me. So it's just a matter of going to PCBWay.com, quick order PCB, add my Gerber file, pick my color, so black. Everything else is all good, and save to cart. And then fast forward 1 week, and let's see what we got. Well, my delivery from PCBWay has arrived, and so let's take a look. So I'll just grab out the CPU PCBs. They were packed really well, which is great. And I'll just pull out one of the PCBs, and they look fantastic. They've done a really good job. The silk screen is super sharp. Yeah, they just look great. Okay, so let's get building. So first I'll gather up the parts that I need. So we've got the sockets for the CPU and the VIA, and also the glue logic, a resistor pack, some decoupling caps, pin headers, the crystal, and we'll get some resistors as well. Okay, time to get these on the board. So I always start off with the shortest components and work my way up to the taller ones. So usually that means resistors first. And so we'll get those in. Next up is the sockets. So I solder opposite corners of each socket first, just to make sure they're seated correctly, and then go ahead and solder all of the pins. So I know these soldering time lapses can be a bit boring. If you'd like me to omit these from future videos, let me know in the comments below. So next up is the resistor pack, and this is used just to pull the data lines low. Then the crystal, and the various pin headers, which are used for configuration jumpers. So these blue ones I'm using for SPI. I've got 3 SPI ports in total, running off port B on the VIA. Okay, now the decoupling caps go in. And lastly, the double row pin headers which go to the bus. So here I use a female connector just to keep the 2 pin headers in line. And that's it. So this board is complete, so I'll just clean it up. And a quick test for the power connections. I don't want any shorts, and just want to make sure they're all connected correctly. So now it's time to put the chips in the board, so I'll just gather them up. So we've got the CPU, the VIA, the 2 GALs, and a 7474 flip-flop for the clock. And also the configuration jumpers, so it's just 1 for the oscillator and 2 for the clock to set it to full speed. That's it, so let's give it a test. Out with the old and in with the new. So as you can see, there's another new card in there. That's actually the TMS 9918 VDP. So I did actually build that one first, but I'll be releasing its video next. Okay, that's not a good sign. We can see we've got signal, but nothing on screen. Just reset it. Same deal. Okay, so there seems to be something wrong. Need to work out what it is. So it's time to bust out the oscilloscope. So this is a new toy for me, so I'm actually a little bit excited that I get to diagnose an issue with it. So turn it on. Okay, so I'm going to hook up a ground connection first, but my plan is to let's have a look at the clock and make sure that's working. And I think I'll also take a look at a data line at the same time and see if there's any activity on the data bus. Okay, so straight away that does not look right. The clock looks fine, I think, but that data line, it looks like it's floating here. And also if I scroll left, yeah, so it also looks like we're not getting a 1 or a 0, not getting 5 volts or 0 volts there. So my guess is we've got some bus contention, so I must have something miswired. Let's take a look at the schematic. So if I take a look at the schematic, and we can see here I've hooked up the read-write pin to the read signal, which is active low. So if we take a look at the data sheet, we can see once we get to the pin read-write. So read-write output signal is used to control data transfer. When in a higher state, the microprocessor is reading data. So what I've done is reversed that on the schematic. A bit unfortunate. So I'll just, if I fix that here, which means these need to be reversed as well. And also the interrupt. And to the via as well. Okay, so now I need to come up with a bodge, and if we just take a look at the PCB, let's have a look here. So we've got read and write here, and it looks like unfortunately the right pin goes to an internal layer. That's my VCC layer. If we turn the copper on, yeah, VCC layer. That's my ground layer. So what we need to do, I need to reverse these, and it looks like the read line should be easy enough to do. There's a trace on the back, so I can cut that and route that through to write. Now this one here, so that's an internal layer, and then here it goes to the back. So it looks like we can probably cut that. We can probably cut that either here on the front or here on the back. Yeah, so I think we'll cut this one here on the back as well, and then we'll solder from this via through to the read pin, and that should be an okay fix. So this black solder mask looks great, but it is very opaque, which makes this quite tricky to do. So I'll do the read pin first, which is the easier one, and just verify that the connection has been cut. So I'll do this by doing multiple cuts along the trace. Counting the pins to try and get the right one. Okay, that looks good, so that's broken now. Yep. Okay, so moving on to the right pin. Again, very hard to see where exactly I need to cut. And also very, very small. I think I should really get myself a microscope. It would help a lot with this sort of thing. So I'll just test this one. And it looks like the connection is broken, but I think I'll just give it one more cut just to be sure. Test it again. Yep, looks good. Okay, so now I need to remake those connections. So I'm hoping to just remelt the solder on that pin and stuff the wire into the gap. It might not fit in there though. Yeah, okay, so I don't think that's going to work. Just give it one last try. No, I'm going to have to suck the solder out of there. So let's do that. Okay, we'll try the wire again. This time I can actually get it in the gap, which is a good start. And put a bit of solder on there. Looks good. Okay, I'll just fast forward the rest of the connections. You get the idea. Now, I did say I was going to connect to the vias, but that turned out to be far too difficult. They're just way too small. So I've gone back to the source pins. all good. Okay, so just check the connections. They're good. Alright, let's test it. The moment of truth. Yes, it works. Awesome. Okay, so that's great. That turned out to be a relatively simple fix. And I just need to update the PCB, I guess, for the next revision. So I had planned to cover some of the 6522 development as well, but this video's taken a bit too long due to the fixes, so I'll cover that in a future video. Thanks for watching. See ya.